Good morning. Chapter 6, Lesson 5 is on page 279. Today we're going to be factoring ax squared plus bx plus c. We're going to have a coefficient in the first term of x squared. Chapter 6, Lesson 4, we just had a was always 1. Let's give it a shot, see what we can do. Again, we always want to make sure we understand what ax squared plus bx plus c are going to look like. So we find out excuse me, that a is equal to 2, b is equal to minus 7, and c is going to be equal to 4. Just comparing ax squared plus bx plus c, the quadratic trinomial. So ac is going to go in our multiplying cross, and a times c turns out to be negative 8. That's 2 times negative 4. And we're going to put that negative 7 down in the bottom. That's always that b term, that coefficient in front of the x. So let's think about a product of two numbers that turns out to be negative 8, and yet their sum turns out to be minus 7. And I think we can use a negative 8 and a plus 1. Negative 8 times positive 1 is a negative 8, and a negative 8 plus 1 is a negative 7. So we have to place a minus 8x, and we have to place a 1x. Let's go to our box. Remember, we always stick in ax squared in the upper left, so that's going to be 2x squared. In the lower right is always going to be that c term, which is a minus 4. And we have a minus 8x and a 1x to place. So let's stick the 8x in negative, in the upper right, and 1x in the lower left. Again, we're just finding the sides that give us the areas in the box, the opposite of chapter 5. So in order to get an area of 2x squared, we're going to try an area of 2x, and obviously the other area must be x. 2x times x gives me 2x squared. If this area is, this length already, is 2x, then this length in the upper right side must be a minus 4. If this area of this distance, lower left box is already x, well then this other side must be, let's fix that, must be a plus 1. And if this side is a plus 1 and this side down here is a minus 4, our final check gives us that area in the lower right corner of minus 4. So again, we have the two factors we need, and we can write them out as x minus 4 times 2x plus 1. And if we FOIL those, we do indeed end up with 2x squared minus 7x minus 4. Let's try number 23. 49 minus 42b plus 9b squared. Again, this problem is on page 279. Looks a little freaky for me because things are commutative. I'm going to rewrite it as 9b squared minus 42b plus 49. And I'm going to say this is ax squared plus bx plus c, and the b is the x. That's all the difference. So we have a is going to be equal to 9, b is going to be equal to negative 42, and c is going to be equal to 49. So in our cross we have a times c, which is 9 times 49, and that turns out to be, I believe, 441. So we've got 441 in the top. We have to have a sum, negative b, of negative 42. So let's think about this, and kind of, just because I've done this for a while, the two terms turn out to be minus 21 and minus 21. And let's check. Negative 21 plus a negative 21 gives me that negative 42, and lo and behold, 21 times 21, both negative, will turn out to be a positive 441. So we end up with our two terms, minus 21b and another minus 21b. So let's go into our box and place the things we need to. Upper left, we're going to put in 9b squared. Lower right, we're going to put in the 49, and minus 21b and minus 21b go in the upper right and lower left boxes. 9b squared, well, that turns out to be 3b and 3b as the two sides. And if this side is already 3b in the upper right, then the upper right other side turns out to be minus 7. And if in the lower left we have one side as already 3b, then the other side has to be a minus 7. And we have minus 7 and a minus 7. And lo and behold, those give us the final area in the lower right corner of 49. We have our two solutions, 3b minus 7 and 3b minus 7. So our solution turns out to be 3b minus 7 squared. We could have done this with a trinomial square, realizing that 9b squared minus 42b plus 49 was a trinomial square, just like we did in chapter 3. And if we do that, we come up with exactly the same answers. Not a problem which way you decide to do it. See you all tomorrow.